Okay, so here we have a triangle and a rectangle. Each of them has what I would consider a base, as if it's sitting on a table, and that base, it has a length of 6 units. The line is 6 spaces long. And each of them has an equivalent height of 4 units. I can count 1, 2, 3, 4. You count all the way from point to point. It doesn't matter if the entire square is filled in. When you measure a length, a distance, you're just measuring a one-dimensional line. So the height is 4, the base is 6. Here, we also have a base of 6 and a height of 4. From this point to this point, it's 4 units. Well, if I counted all the squares in here, I'd get 24, because in order to find the area of a rectangle, I can just do base times height. But for a triangle, if I do the same thing of base times height, I would get 24, but it's obvious that there are less squares in this area than in this entire rectangular area. And in fact, there are half. So I'd have to take base times height and multiply that by 1/2, because it's half of the rectangle. It's half of the equivalent base and height rectangle. So the formula for a triangle is always base times height, but then times 1/2. Did I mention it's half? So what if I had a triangle that had a base of 2 units, and then what if I stretched it out to put it way over here? Like this is a really crazy looking sort of scalene triangle. But the base is still 2 units. From this vertex to this vertex is 2 spaces. Now to figure out what the height is, I could deconstruct this and rearrange it to try and make it into a rectangle or a square, but it's more important to just understand that I can just figure out a height so that the height is perpendicular to the base of the triangle. It makes a right angle. And the height here stops at the given height, that's a dashed line, of the highest point of the triangle. So the height here is 3 units. So you might say, okay, then the area is simply 2 times 3. But that would be if it's a rectangle. This triangle is actually half the amount of a rectangle that would have a base of 2 and a height of 3. So you got to do 2 times 3, but then multiply it by 1/2. So 6 times 1/2, half of 6 is 3. This triangle has an area of 3 square units right here. 3 square units. No matter how the triangle looks, you have to find the height so it's perpendicular to the base and it goes as tall as the opposite vertex of the triangle. Hope this helped. Thanks.